Right, guys, so welcome back, and this is our second lesson for modern physics, this topic. And we're going to be looking at atomic structure. So for the past lesson, we've been having a history lesson on how the model of atom has improved throughout the year. So first we started with John Dalton saying that atom is a small ball and that cannot be breaking down into any other smaller parts. Okay, remember you have to say it's the smallest particle or smallest ball, smallest particle that makes everything. It cannot be break down into other parts. And then with the experiment, we find out that, oh yeah, actually atom can be break down. There's electrons inside. So then we have the J.J. Thompson model, which is called the plum pudding model. So the pudding is the atom. And then inside the atom, there are negative plums that's evenly distributed. And the sphere itself, it has a positive charge, and that positive charge will balance out the negative electrons. Okay, so 4 positive charge and 4 electrons. Okay, so and then after that, we have Ernest Rutherford's famous gold foil experiment. The gold foil experiment, and there are 3 observations. So have a think, what are the 3 observations? And then have a think, so what are the 3 conclusions that he made? So with the thing they use is the alpha particle. The alpha particle smashes at the very, very thin gold foil and then comes out and then observe what's happening. Well, first one is most alpha particles went straight through. If Actually, you can stop the video now. Just have a think, like before I tell you the answer. Have a think, see if you still remember it, because you need to remember this for the test. Okay. Yeah. So what are the 3 observations? What are the 3 conclusions? Okay. So I'm gonna mention it now. So 3 observation is the first one is most of the alpha particle just went straight through. So what is the conclusion he made according to that observation? Is that the atom is mostly made out of empty space. Most of the atom is just empty space. There's nothing there. So if you just write that is achieved. So for your test, okay. All right. See. So the second one is, what is the second observation? Second observation is a few of the alpha particles has been deflected with an angle. Okay, deflected means it's changed its direction. Okay, why does it change direction? The conclusion is, so the atom must have this very, very small thing in the middle called the nucleus, and this nucleus must be positive charge. It's very small, so very few can come close to it and then being deflected. It is a positive charge because in order for it to be deflected, it has to have a force pushing this away. So that proves that it's a positive charge. Okay, and then the third observation is very few has been knocked backwards. Okay, if they've been knocked backwards, very few. That again, it proves that this is the nucleus is very, very small, and also it proves that nucleus is very, very dense, and it contains most of the atom's mass. The reason why is because because the alpha particle is very dense. So if the nucleus is not dense, the alpha particle will knock this away and then just keep going. But it got bounced backwards. If it got bounced backwards, that means this is very, very dense, the nucleus. Okay. All right. So so today, finally, we're going to be talking about proton, neutron, and electron, because that was what people have found out after Rutherford's time. So it's actually Rutherford's students. It's called Bohr. So Bohr, he started his own model after that. It's because of the discovery of proton and neutron. So they did a lot of calculation. They found out like the charge and the mass. So if the only proton exists and the numbers they got does not add up, so they realized, okay, there must be something else inside the nucleus, and then so that something else is turned out to be neutrons. So now you guys all know neutron exists, right? Okay, sweet. So let's have a look of the notes that I've given you guys. And so normally we have an element. So say the example I give you is carbon. So the element, we got the periodic table of elements. So the element is C. Carbon is C. Okay. So what determines something to become a carbon? Say this. So one day you are just walking around or doing experiments in the lab, and then you found out, oh, I found a new atom. Well, this is a new atom. Well, it's just a pen, but let's just put, oh, I found a new atom. I found an atom. So is this a new atom that human has not been discovered, like we have never seen this before, or is this actually an element that we've already known about? So what determines what kind of element this is? So we are looking at the number of protons. Okay, so the number of protons is the most important out of these three elements, so three particles, so proton, neutron, electron, because the proton number tells you what element it is. So if you break it apart and you have a count 1, 2, 3, 4, 5, 6, 7, or let's say 6. Oh, you got 6 protons. If you got 6 protons, this is a carbon atom. Okay, and it does not matter how many neutrons you have or electron have. As long as it has 6 protons, it's a carbon. If it has 8 protons, it's oxygen. Okay, if it's only 1 proton, it's a hydrogen. So it does not matter how many neutrons they have. Okay, so and this number we give it a name. We call it the atomic number. So the atomic number equals to the proton number. Okay, and then the other big number in there is called the mass number, which is 12. Okay, so what is mass number? So on the right side, I've explained. So proton and neutron are very heavy. If they're heavy, they're almost exactly same mass, and we sometimes when we're dealing with very small mass, we need to give it a new unit. We call it atomic mass unit. Okay, so you can write that into your notes. So what is atomic mass unit? AMU is atomic mass unit. So one proton, the amount of mass one proton have is 1 atomic mass unit. The amount of mass 1 neutron have is also 1 atomic mass unit. So atomic mass unit is just the weight of a proton or a neutron. Okay, all right. So that's why these two are heavy. Then they consider to become the mass number. Okay. However, electrons are very, very light. So if electrons are very, very light, we can't consider into the mass. So what is the mass number? The mass number is the number of proton and the number of electron, or the number of neutron together. Okay. All right. So from this one we know. Okay. So for carbon, there are 6 protons because the atomic number is 6, and then the neutron number is going to be 6 as well. That's because the total mass is 12 minus the 6. So we get 6 neutrons, okay? But this is not always true, like in terms of, we think for this one, it's like the proton number equal to the neutron number, but this is not always true, okay? So sometimes they equal to each other. You look at a lot of the small ones, they might equal to each other. That is just a coincidence, okay? So it does not need to equal to each other. So you find a periodic table, you go find an element, then you will see some of them, the proton number and the neutron number does not equal to each other. So it's very important if a question asks you the number of neutrons, then you need to use the mass minus the proton number. Okay, all right. So the next thing is for an atom is like the proton. If it's an atom, okay, atom no charge. Atom has no charge. If it has a charge, you learned chemistry last year, year 11. If it has charge, then it becomes an ion. Okay, gaining, losing electron become ion. The proton number will equal to the electron number, right? Okay, see. So over here we have another word, keyword. The keyword is called nucleon. So what is a nucleon? Nucleon is a proton or a neutron. So proton and neutron are actually very, very similar. So they are, so later people also find out they're actually made out of something called a quark. So they are up quark, down quark, charm quark, and strange quark, top quark, down quark. So there are 6 different quarks. So proton and neutron are made out of quarks. So they're very similar, and we call these the nucleons, and because they're inside the nucleus. So say this, I ask you for this carbon element, carbon atom that I've written down here, and what is the number of neutrons they have? So we will have 12 neutrons. Okay, so that's 6 protons and 6 neutrons. Okay, and mass number we use the symbol A, and atomic number we use the symbol Z over here. All right, and then let's move on to the next part. The next part says I have a key concept called isotopes. So what is isotopes? So isotopes is if there are 2 atoms, let's say there are 2 atoms. These 2 atoms have exactly same number of protons, then they're the same element, because protons determines what element it is. Say for example, I've drawn you 3 hydrogen here. These 3 hydrogen are all hydrogen. That's why I write H over there. That's because the atomic number is all 1. That means they only have one proton. But if we have a look, the first one is called protium. So protium, let's have a look. How many neutrons does it have? So the mass is 1, the proton is 1, the neutron is 0. Okay, so it does not have any neutron, it's just a proton itself. Well, we look at the second one called deuterium. Deuterium have 2 mass, so that means there's actually 1 proton. So 2 mass, 1 proton, that means there's 1 neutron. Okay, so and then tritium have 2 neutrons. Okay, so you can see the protons are the same, but then the neutrons are different, and these are called the 3 different isotopes of hydrogen. Okay, and then we look at the carbon-12 and carbon-14, and they are the 2 different isotopes of carbon. The uranium and 238 and 235, they're 2 different isotopes of uranium. And you might ask, well, how come it to be? Like, why would an element have these 2 different isotopes? So, like, which one, like, do we encounter? So, the most common one that you see the element is all in the periodic table. Okay, so if you go to the periodic table, you will see the hydrogen will be 1, 1. The mass is 1 because this hydrogen is the most common one. And then the second one and the deuterium and then the tritium is actually not very common. So, and that is why they're not included in the periodic table, and they are unstable as well. So they're going to go through like radioactivity, which is what you're going to learn next, and then to turn into a common one, which is the first one, the protium. Okay, same with carbon-12 and carbon-14. Like our body, as you know, organic matter are made out of mostly carbon, hydrogen, and oxygen. So say the carbon chain that joins all my body together is mostly carbon-12. Okay. So, but there will be just slightly a little bit of carbon-14 in there, so which we can use it so for something called a carbon dating. So carbon dating is this method you use, say find a skeleton on the ground. In fact, just like 2 days ago, there was a news that someone was digging in Mount Eden, like a house, trying to rebuild a house, and then it turned out to be like a skeleton came out of the ground, off the ground. So if we want to know, okay, how old is this skeleton? When does these people die? We can use this method and to called carbon dating to find out, and we're gonna learn that a bit later in this topic when we deal with half-life. So yeah, so. For now, you just need to know, well, there's carbon-14 in our body as well, and in the trees, and yeah, and these different different isotopes around. Okay, all right. So for isotopes, you really need to remember the definition, and then there might be an explaining question to say, hey, why is this one and this one, say carbon-12 and carbon-14, both carbon, and what are the differences? So you will need to say, well, these are the same element because they have the same number of protons. However, the neutron number are different, so they are called the isotopes. So, and yeah, for explaining questions, always explain the concept first. So that's something you will really need to remember this year. For example, if they ask you about say force causes acceleration, you gotta say, well, this is acceleration and it is caused by a force, and because of Newton's second law, force can cause acceleration if forces are unbalanced. So you gotta just really focus on the concept. Okay, so the concept over here is isotopes. Yeah, all right. So there is one question called radioactive emission, question 1. So in your booklet, so have a look where it is. So you should be able to work on that question. And yeah, so that's it for our lesson today. And hopefully you guys enjoyed that. And if you have any questions, send me email at vwang at apps.school.nz. And if there is any question you have, and then I can explain in the next video to the whole class because they might need help as well. So yeah, that's all I can think of. Have a good day and a good long weekend.